Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students and it's a by request video. A few days ago I handed out some measurement questions for homework and we took some of them up in class, but a request was made that I show the full solution to every question, and so that's what this video is doing. So for those of you who asked, here you go. Let's look at the first question. Oh, and don't forget to have your formula sheet with you because your formulas do not have to be memorized, they just have to be used properly. So, first question says, the cone on the right is 20 centimeters high and has a volume of 1,000 centimeters cubed. What is the radius? So how do you approach a question like this? Well, I always think the first two things are identify clearly what your shape is, and then identify what measurement it is that's primarily important to this question. So for example, this is a cone and it is a volume question. Therefore, the first thing I always do is I write down the equation for the volume of a cone. It's pi r squared h divided by 3, and again, that's on your formula sheet. So now I'm going to reread the question and see what's going on. So the cone on the right is 20 centimeters high. So it's telling me the height is 20 centimeters. And don't forget, height is always identified as something that meets perpendicular to some other part of your diagram. So the height is 20 centimeters. I know the volume is 1,000 centimeters cubed. And it says find the radius. So again, if I look at my formula, I know the volume. I know the height. Of course, I know what pi is. I always do. And the only thing I need to know that I don't know is the radius. So really, this is now just a formula that I can substitute values into and solve for the unknown. So that's what we're going to do. Is take the values you know and sub them in, and then solve for the variable that remains unknown. So the volume is 1,000. Pi is obviously 3.14. Radius, I still don't know, so I still have r squared. Height is 20. And divide by 3, well, that's part of the formula, so it has to be there. So I've substituted everything for what I know, and I'm left with a single variable, which means I can solve. So solve or isolate for the variable using whatever algebraic skills you know. Now, personally, if I'm dividing by 3, I don't like doing that. So to get rid of divide by 3, I'm going to multiply by 3. So multiplying both sides by 3, well, here's 1,000 times 3. And on the other side, this 3 is just going to be canceled out. On the same step, I'm also going to remember when I look at the numerator that I have 3 things multiplied together. And when you multiply, it doesn't matter what order you multiply. So in other words, I'm going to take pi and multiply it by 20 right now. And I'm not going to worry about r squared, except for it still has to be there, obviously. So pi times 20 is 62.8. So I have 62.8 times r squared. So now it looks more like something I'm familiar with, which is an equation I can easily solve for. So to isolate r squared, we divide both sides by 62.8. And so in your calculator, do 3,000 divided by 62.8. And you should get 47.77. It almost looks like I had that answer in advance, but we pretend I don't. What? Okay, so in your calculator, 3,000 divided by 62.8 is 47.77, and that's the value of r squared. And then to get r, if you have r squared, you simply take the square root of both sides. So on the right, the square root of something squared, well, they just cancel each other out. And the square root of 47.77, rounded correctly to 1 decimal place, is 6.9. So therefore, the radius is 6.9 centimeters. So again, hopefully a fairly straightforward question where we're using a standard formula. It just, instead of solving for volume, we have to rearrange it and solve for r. Good, so let's look at the next question. It says triangle KLM is shown on the right. So here's the triangle, and remember that triangles are identified by their vertices, and their vertices are always labeled with capital letters. So this is triangle KLM. What is the perimeter of the triangle? So this is one where I hope no one needs to look at their formula sheet. Perimeter is simply add up the sides, and of course a triangle has 3 sides. Now the problem, of course, is I don't know the length of this side. So I can't just answer the question in 1 second. I'm going to have to do a bit of math. How do I find the length of that missing side? Well, I'm sure you've already noticed that this is a right-angled triangle, and therefore I can use the Pythagorean theorem. So remember, the Pythagorean theorem is not given to you on any formula sheet. It must be memorized. And, of course, it must be used properly. And part of using it properly is properly identifying which sides of your triangle belong to the letters A, B, and C. And, of course, the most important one is the hypotenuse. The side opposite the right angle is always labeled with C. The other two sides, I don't care which one's A and which one's B. I personally have a habit where the side that I know is A and the side I don't know is B. That's just a habit I have. You don't have to follow my habits, but you must label this one, the 7.3 centimeter side, as C. So now I'm going to substitute into the formula. So 7.3 squared is equal to A squared plus, now I don't know B, so I still write B squared. And then because it's the Pythagorean theorem, the first thing I'm going to do is rewrite it where it becomes a subtraction statement. So again, all I'm doing is I'm trying to isolate B squared. And in order to isolate B squared, I can't be adding 4.2 squared. And the opposite of plus 4.2 squared is minus 4.2 squared. This is the point where I take out my calculator. And depending on your calculator, hopefully you have a scientific calculator so you can do this all at once in your calculator. So I type in 7.3 squared, subtract 4.2 squared, and I get 35.65. And that's what B squared equals. So again, if I want to find B, I need to take the square root of both sides. So the square root of B squared is just B. And the square root of 35.65 is 5.97. So if I round to one decimal place, that's 6.0. So the length of this third side of the triangle, I now know it's 6.0 centimeters, which means now I can find the perimeter of that triangle. So the perimeter is, add up all the sides, perimeter is 7.3 plus 4.2 plus 6.0, which is 17.5, and it was measured in centimeters. Okay, so hopefully a nice straightforward question, Pythagorean theorem, and perimeter. Let's move to question 3. It says the frame of a roof of a small house is being constructed. A portion of the frame consists of 4 isosceles triangles as shown. So in the diagram, you can clearly see 1, 2, 3, 4, and they're isosceles triangles because each of them has 2 sides that are marked as the same length. So in this question, I'm supposed to do this. What is the total length of the 3 sides that form the shaded interior angle? So if I look at this, there's the shaded interior angle, and I want the total length of the 3 sides. So really, this is a question saying find the perimeter of that shaded triangle. And I already know that one side is 6.1 meters, so that's nice that I know that. And I just have to find the length of the other 2 sides. And you'll notice the other 2 sides are the same length. And not only that, but those 2 sides are the same length as this side, this side, this side, and this side. So every side, every length that is noted with that ticky is the same length. And of course here, those 2 tickies together equal 7.4 meters. So to be formal about it, I'm going to call that length, that ticky length, x. And that way I can write a statement like x plus x equals 7.4 meters. And again, I get that by looking at this side of the whole diagram. And so 2x equals 7.4, and therefore divide by 2 on both sides, x equals 3.7 meters. So now, when I look at my diagram, let me clean it up a little bit, every side, or every length that is identified with that red ticky is 3.7 meters. And you'll notice that the triangle that I'm most interested in has 2 red tickies, which means I can now find the perimeter of that triangle because it must be 6.1 plus one of the tickies, oops, which was a 3, not a 2, plus another ticky. So altogether, I get a perimeter of 13.5, and it's measured in meters. So again, hopefully a fairly straightforward question. The most important part of this question, I think, is making sure that you know that even though it looks like there's a lot of information in this diagram, there's a lot of information that you don't need. So being able to think about and judge what information is important and what information isn't. Okay, let's look at question 4. It says a soccer goalie is standing in a goal opening. From this position, she can guard the area represented by the semicircle shown. How much of the goal is she not guarding? So we know that this is an area question. First of all, it says so, but of course we know it's area anyway, because when you guard a goal, you don't only guard the perimeter. That doesn't make sense. And it's not a volume question because there's no indication of 3 dimensions. And of course, if you know the game of soccer, it doesn't matter how deep your ball goes into the net. It only matters that your ball goes past sort of this line right here. So it's an area question. And in particular, what it's asking for is the area that she cannot guard. Well, the semicircle, oops, hold on, I didn't want that color for a reason. The semicircle is the area that she can guard. So because of her, arm reach and her physical athleticism, whatever, this is the area that she can guard really well. So if someone kicks a ball and the ball goes into this area, she's going to stop the ball from scoring. Yay! That's her guard area. Now that means that there's an area she's unable to guard, and that's what's left over in the soccer goal. So I'm identifying it with green. And the question says, basically, what is this green area? What is the total area that she's unable to guard? So how do we find it? I mean, obviously, we are not going to try to find the area of a shape that looks like this, because what shape is that, right? This shape here is a very strange shape. Or is it? What you should see is you should see a rectangle with a piece missing. So the part in green that I'm looking for is the green rectangle minus the red semicircle. So all we have to do is treat this as a composite diagram in which we're going to subtract areas. So first, let's find the area of the entire net, or the entire goal. So the area of the rectangle is, so area is length times width, so 7.3 times 2.4, and in your calculator you should get, 17.52 square meters. So if the goalie wasn't anywhere here, if she was, say, over here talking to the referee, then there would be 17.52 meters of unguarded net. However, that's not where she is. She's here where she's supposed to be, and therefore she can guard this whole area, the red. So let's figure out what she can guard. So the area of the semicircle is, so it's half a circle. So you take circle, pi r squared, and you divide by 2 because it's half a circle. And what's the radius of that circle? Well, if you look back at the original diagram, the radius is 2.4. So sub that into the formula. So pi times 2.4 squared, and then divide by 2. So when you, divide by 2, I don't know why I put the 2 there. I'm just going to blame the pen. When all else fails, you blame technology, right? Okay, so 2.4 times 2.4 times pi, divided by 2, I get 9.04. So the area of the semicircle that she can guard is 9.04 meters, and therefore the unguarded area is the difference between them, which was 17.52 minus 9.04, which is doing math in my head, which is 8.48, I hope that's right, meters squared. Okay, so hopefully you understand the concept of subtracting to find an interesting shaped area, and that's part of working with composite figures. Okay, so that was question 4. This video is about out of time, so I will meet you on the next video. I'll see you there.